So we are starting this question. A body of mass m is lying on a rough inclined plane of inclination 30 degree. Find the magnitude of force applied horizontally to make make the block move up the incline. Okay, so if we have a block or a body like this on an incline of inclination 30 degree, and we have an object here. So if a force is applied horizontally, okay, and the friction coefficient is given 0.2, all the things, masses are given. Find the magnitude of force applied horizontally to make the body move up the incline. So how do we solve this question? So first we will write all the forces. So first is mg downward, then normal. If we are trying to move it up the incline, friction will be like this. Okay, so the forces are like this. Normal, this is normal, this is external force, this is external force, this is mg, and then there is friction like this. So these are the forces, and we consider this along x direction and this along y direction. So these are x and y directions. So the components we will write along x and y. So first we are writing along y. Along y, equation along y direction. What are the different forces along y? So you can see along plus y direction there is a normal. In plus y direction there is a normal. Normal is along this line. So we will have normal. Then mg is like this. So mg component along negative y direction, that is mg cos 30. Mg is downward. So mg component along y direction, mg cos 30 minus mg cos 30 degree. And then we have f naught like this. So f naught component along y direction, this will be the component. So this is 30 degree. So component of f naught, this is f naught. F naught component along y direction, that will be f naught sin 30. F naught sin 30. This is also along negative y direction. You can see that mg cos 30 is along negative y direction and f naught sin 30 is also along negative y direction. So you can write it like this. This should be equal to 0 because along y direction there is no acceleration. So this is the equation. Now along x direction, if we write, so along x we can write the f naught, and you can see f naught is there. F naught cos 30 is up the incline. F naught cos 30 is up the incline. F naught cos 30 is up the incline, and it should overcome the down the incline forces. Okay, so this f naught cos 30 must be equal to the down the incline forces. You can see the friction. Down the incline forces are friction, equal to friction, and then we have this is friction, and then we have mg sin 30. Mg sin 30. Okay, so in this way we can write. Now friction is what? Mu times normal plus mg sin 30. So we can replace the normal force and we can have mg cos 30 minus f naught sin 30 into mu plus mg sin 30. We can write it like this. Okay, so f naught we can take together. It will be f naught cos 30 plus f naught mu sin 30. Okay, we can write it like this, and then here this side we will have So this is how much is this? Mu times normal. So normal is what? Normal is addition of these two. Okay, so this was plus. This both are plus. So here it will be, here it is plus sign. Okay, if it is plus sign, then if not, it will become minus. It is minus here, and it is mu mg cos 30 degree plus mg sin 30 degree. Okay, so in this way we can write. Now f naught is how much? It is mg mu cos 30 degree plus sin 30 degree divided by cos 30 degree minus mu sin 30 degree. So this way we can do. So put all the values now. 2 kg, 2 into 10, mu is 0.2, cos 30 is root 3 by 2 plus half divided by cos 30 is root 3 by 2 minus 0.2 into sin 30. Sin 30 is half. Okay, in this way we can do. So we are having 20 and 0.2 into root 3 plus 1 divided by root 3 minus 0.2. So whatever we get, this will be the answer. This is the answer for this question. This much force we are going to get.